Hey everyone, welcome back to my channel. Today we are diving into the fascinating world of exploring R in bioinformatics. Now you might be wondering, why should I care about explore R in bioinformatics? Well, my friend, let me tell you, this is one of the most crucial aspects of modern research and data analysis in the biological science. So buckle up and get ready to have your mind blown. If you haven't already subscribed my channel, I encourage you to do so for the most up-to-date videos and the solution related to the bioinformatics. In the previous video, we covered about objects, classes in R. Now, in this video, we are discussing about models and formula in R. So, we are using kind of this formula y is equal to x plus x1 plus x2. This is the simple equations, and we are about to explore some built-in data sets. These data sets are freely available for experimentations and allowing us to try out various examples involving packages, models, and more. So we are focusing on iris dataset. So we create a dataset variable name, and we are working with iris datasets. As you can see, when I type IRI, and automatically the drop down will come, and it's Edgar Anderson iris data, this famous Fishers and Anderson's iris data. So a lot of videos you will also find on YouTube with this data. So we are also using this data. Now you can see in the top of the environment, we can see 150 observation of 5 variables. We can click on this and kind of Excel sheet will be open, and in this view we have a three different types of species: sepal length, sepal width, petal length, petal width, and species. Okay, so including measurements with the different sepal lengths, petal lengths, sepal width, and petal width, we have to work further with the formulas and create a model. Okay, so now we have to close this and return to our spreadsheet. So now imagine you are working on the large data sets, something like gene expression data, where we having a thousands of genes, like 20,000 plus genes, and you are dealing with more than this genes also. N number of rows are there. So if you were print the entire data sets, your computer will spend a significant amount of time to print the list, and it will be print again and again and again and again, and it will take your time. So sometimes you might want to get a glimpse of your data sets to ensure that it's there and the columns are as expected. So achieve this, we can use the head command, where we use the head command, and we print the data sets, and now enter. So you can see it will give the top 6 rows from the data sets. Now for below rows, you can use tail command. So you will get the data from the below 6 rows. Now I am going to print data set. See, it will be too fast, but if it will be the more than 20,000 genes, so then it will be take time, and you will just dragging it to the bottom and scrolling it to above. If you don't know the number of rows in your data sets, like in genome sequencing, after the data will come, and when you are doing for the gene expressions and certain other things, so that time you don't know how much the rows are there, so we use the nrow command and function and to data set, so it will give you the number of rows present in the data set. Similarly with the number of columns, so n col and data set is 5. We have 5 number of data sets. As we can see, there are 5 variables also. Okay, now we can comment this out, and our total number of rows in data set and total number of column in data set. Okay, so now we can move to the linear model. We create some simple linear model. Linear model. So lm dot, we are doing with petals first. Petals, you can choose with sepals also, you can go with sepals also. Creating the parallels. Lm is a linear model, parenthesis, you can see uh, above here it is lm formula. First we write a formula, then which actually does this, and then we use the data sets. We can also use the subset, weights, NF action, methods, QR model, true, x is equal to false, y is equal to false. So we can use this kind of syntax. So first we write formula is equal to petal dot length okay. So here everything is, the petal of the P is capital and the length of the L is capital, so we have to keep this in mind because R is in case sensitive. Petal dot length, petal dot width comma डेटा कहाँ से आएगा हमारा, फ्रॉम डेटा set, because here our data set is a variable with iris data set. Now press enter and we run this lm dot petals, press enter. So this is our formula, like lm is the petal length by petal width and with the data sets as we give above in line of code, and this is our slope, intercept, and this is our coefficient. So let's move to summary function. Okay, summary lm dot petals, press enter. So here is the result. We can see formula, residuals, minimum, median, 3q max, 1 quarter, 3 quarter, coefficients, it gives the coefficients, the value, standard error, t values also given, significant codes, residual, standard error, multiple r squared, adjusted r square, and it also gives us the p value and the f statics. So here we are not focused on that much. We are only focused with the correlations. The greater the correlation is, the stronger the relation with it, and the zero means it has a random, like there is no correlation between the other values, and the p values is significant smaller than 0.05, and this shows that 2.2 into 10 ki power minus 16, that is damn smaller than 0.05, so the data is significant. This means that they have a significant relation with the our petal length with petal width. Okay, so you can also do with the same with the sepal length also. Okay, this is the linear model. You can do various models like regressions and classifications, GLM, general linear model, univariate, bivariate analysis, and so many things are there. So this is just a basic model to teach you and to learn you like how we can manipulate the data, how we can use the data for this. So definitely in future we will also work on that and give you the examples with the perfect code. So yeah, this is it for the today, and in the next video we will do some charts and graphs with this data. And yeah, if you didn't subscribe my channel, definitely go and subscribe my channel and for the updated videos. So see you in the next video.